Hello and welcome to another walkthrough video of IAL Edexcel AS Level Physics. Today we are going to do the walkthrough of Unit 2 exam, which was conducted in October 2025, and it will be really helpful for your upcoming exam in 2 weeks. I wish you all the best. And I made this walkthrough very easy and explanatory for all the concepts and technical glitches such as polarization concepts or the thermistor or electronics, whatever. So I will request you to see the full video, and it will be very beneficial for clearing up your concepts. And please like and subscribe my channel. I really need your support. And if you need any of the help in physics or any private tutoring or classes, you can reach me out on the given contact details on the left hand side of this video. Okay, so let's start. बेटा बात नहीं करनी, ठीक? पापा काम कर रहे हैं. Question number 1. The graph shows how the current I varies with the potential difference for an electrical equipment component. Which of the following components would give this graph? So this is obviously for the filament, because for the filament initially when temperature is low, then the rate of change of current is high. So when the temperature is low, initially resistance is also low, and when the resistance is low, the rate of rise of current is high. So you can see that the graph is shooting up quickly. But in this region, when your temperature is high, here temperature was low, okay? And when in this region the temperature is high, it means the resistance is high. So the rate of rise of current decreases. Therefore, the graph is not shooting up as it was before, but it is still going up, but at a smaller rate. So you can see that this graph shows exactly the behavior of the filament. Question number 2. One thing that you need to be very careful with, there are two kind of graphs that you can see in Edexcel, either IV or VI. So if it is IV, then the graph is this one, okay? And if it is VI, then it is this one. So for the IV graph, the filament looks like this, but for the uh, for the um, for the uh, VI curve, it should be something like that, okay? So you have to be careful with that. So it is like quite opposite to each other. The diagram represents a longitudinal wave. Which of the following is the wavelength of the wave? So it is a typical look of the longitudinal wave, and for the longitudinal wave, you know that where um, particles are close enough, the pressure is high. So this is showing up the compression, and this region where the particles are away, this is showing rarefaction, and this is again compression. This is again rarefaction, compression, rarefaction, and compression. So for longitudinal wave, one complete cycle comprises compression and rarefaction. So from here, another wave is starting. So this is the one complete wave for the longitudinal wave, okay? Because it only has one compression and one rarefaction. So if you are having another compression here, it means another wave is starting. So if this is 2, so it means we have 3 waves here. So each wave will have a wavelength of 2. Therefore, the answer is A. Question number 3. The diagram shows the trace of a sound wave on an oscilloscope. One horizontal division represents a time of 5 milliseconds. Which of the following expressions gives the frequency of the sound waves in hertz? This is the typical screenshot of the screen of cathode ray oscilloscope. So on the y-axis, you always have voltage, and on the x-axis, you always have time. Okay, so you can easily see that one wave is being completed here. So if this one box is 5 millisecond, then 5, 5, 5, and 5. So it means one wave time period is 20 milliseconds. So 20 millisecond means 4 times 0.005. This is the time period, and if you do the inverse of it, 1 over t, you will get the frequency. Okay, so if you see that, the answer for this is D. Yeah, this is the answer. Okay. An electron has a velocity of 2 into 10 raised to the power 7 meter per second. Which of the following expression gives the de Broglie wavelength of electron in meters? So de Broglie wavelength is simply lambda equals h over p, where p is momentum, so it will be written as 9 m into v, and Planck's constant is 6.63 10 raised to the power minus 34. Mass of the electron is 9.1 into 10 raised to the power minus 31, and the speed, which is given as 2 into this. So you can see the option here, and the option is, I believe, B. Okay. Question number 5. 2 points on a wave have a phase difference of 25. Which of the following expression give the phase difference in radians? So all you need to do is just to do 25 times pi over 180. Since you don't have pi over 180 here, so you just do 2 divided by 2. So it will be 2 pi over 360. So the answer is A. A bat is an animal that locates objects using a pulse echo technique. A bat emits a pulse of sound wave that travels to an object. The bat detects the reflected pulse 4 milliseconds later. Speed of the sound is 340 meter per second. Which of the following expressions give the distance in meters between the bat and the object? So this is your bat, and this is your prey, for example, and it is throwing out the ultrasound waves, and the ultrasound waves are coming back, right? So this distance is d, and this distance is also d. So the speed which is with which the um, ultrasounds are going is v, and the time which is given here is 4 millisecond of detection. So it means the distance traveled this way and the distance traveled back this way, it is like 2 millisecond to go and 2 millisecond to come back. So it means in total it is covering 4 milliseconds. So from here the velocity will be, because the wave is covering the double distance, so 2d over time, and from here d will be 2 v into t divided by 2. So just v is 340, time is 4 into 10 raised to the power minus 3 because it is millisecond, and 2. So whatever the answer is for this one, I believe it is D, right? Yeah. Okay. A string vibrates between two fixed points. The diagram shows the stationary waveform on a string. When the string vibrates, the frequency of vibration is adjusted until the same shape of standing wave formed on the string. Which of the following expressions give the frequency f of the new standing wave? So first of all, see that what is the formula for the frequency of standing waves in a stretched string? Because when you have a stretched string, you have a tension. And this is the formula. Now they're saying you have double the tension. So when you double the tension, you have to put this. And when this 2 will come out, this will become under root 2 times 1 over 2 pi t over mu. And this whole thing is actually what? F, if you see that. So you can replace it with this 2 into this whole thing can be replaced with frequency. So this should be your answer. And therefore, right away, the option is B. Okay. A student connects 5 identical 1.5 volt cells in parallel to form a battery. Each cell has an internal resistance of 1. Which row of the table gives the EMF and the internal resistance of the battery? Okay, so here is Let me draw them again. So this is one resistor, this is second resistor, this is third resistor, this is for resistor, sorry, not resistor. Oh, my apology. Batteries. 1, 2, 3, 4, and 5. One leg should be bigger and the second should be smaller because bigger leg shows positive, smaller leg shows negative. Now you know that when they're connected in parallel like that, their voltages will remain same because in parallel you don't have the value of the voltage change. So if it is 1.5, 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 in parallel they are not going to be added in each other. So the total voltage has to be the same 1.5. If it was in series connection, then the voltages should have definitely be added up to 7.5 for each 1.5 volt cell, but here you have parallel combination to make sure that the voltage never changes in parallel. However, every battery has a small internal resistance as well, and you can easily see that these 5 internal resistances are connected in parallel as well. So for this combination, the total resistance will definitely be added up just like any other resistances, and for that you have to do this 1 over 1, 1 over 1, since we know that the parallel resistances are added in that way. So 1 over R is going to be like 5 because 1 over 1 is simply 1, right? So 1 over 1 is simply 1 plus 1 plus 1 plus 1 plus 1 plus 1. So from here, 1 over R is 5, and from here, R is 1 over 5. So option is 0.2. So from here, your internal resistance is 0.2, and your EMF is 5, and therefore answer should be A. The diagram shows the energy levels in an atom. When the electron moves from N4 to the ground state, a photon of a frequency F is emitted. Which of the following photon frequencies could not be emitted by this atom? Well, um, here you can see that if it is moving from here to here, the frequency F is being emitted. So you can see that the energy difference is maximum, right? As you know that the energy of the emitted photon is HF. So from here, energy is directly proportional to frequency. So here the frequency is maximum, so the energy is also maximum, okay? So this is showing up the maximum energy. Now, if it is not moving to, there are 4 shells, right? So if it is not moving to N1 and rather it is moving to N2, what will be the frequency? It is going to be definitely less than F max because uh, F is showing the maximum energy, but here from the N4 to N2, the energy is not maximum, it's just 4 minus 1 is 5, all right? I mean 3, but for 1 minus 5, it's going to be 4, right? So so here, if the energy, if you see here, the energy is like 5 minus 1 is like 4, and from here 4 minus 1, the energy is like 3. So the energy is like 75% here of the previous one. So here the frequency should be frequent 3 by 4, which shows the 75% of the frequency as well. Okay, because the energy is now reduced to 75, so the frequency has to be reduced to 75 as well. And similarly, if you move to this one, the frequency should be half of the previous one now, because previously was 100% up to here, then this is 75% and this is 50, and no other transaction is possible now, right? So you cannot say that I mean the frequency can be like f over 4 or something. So what I know or what I believe, maybe from here to here, or maybe from here to here, whatever you get, it can be maximum up to quarters. So this one is definitely not being fitted anywhere in this combination of the emitted photon energy. So therefore, it is extremely small than the possible combinations. Therefore, I'll say f over 8 is the only option. Okay. Question number 10. The diagram shows a 4 ohm resistor connected to a cell of EMF 12 volt and internal resistance 2 ohms. Which of the following expressions gives the potential difference V across the internal resistance of the cell? V equals 12 times. Okay. So they're actually asking you to find out the voltage here, and it is an ideal example of finding the unknown voltage using the potential divider equation. And for the potential divider equation, you know that the small v over capital V equals small r over capital R. Here the small v is the one which you need to find. So unknown, this is unknown voltage. Okay, and this is the unknown component voltage. Okay, and this is unknown component resistance. All right, unknown V component resistance, and this is total resistance, and this is total voltage. So small v is the one definitely you are going to find. So I am replacing small v over capital V equals small r over capital R again. So small v is unknown. Capital V is the total voltage. The total voltage is definitely here 12, which is given in the question. Now small r is 2 for the unknown component. You don't know the voltage, but you know this resistance of that unknown voltage component resistor, which is internal resistance. And R is a total resistance, and the total resistance for series combination, as you can see, it is a series combination because there is only single path available for the electrons to flow. There is no other or multiple paths available. If you don't have multiple paths available for the electron to flow, then that circuit is called series circuit. So for series circuit, you always add up the resistances. So here is your answer. V over 12 equals 2 over 6. So from here, small v should be 2 by 6 times 12. And you can see that the option for this one is D. Okay, so here's the end of the MCQs. Now let's move on to the section B. Well, the section B is a wire of cross-sectional area 2.8 times 10 raised to the power minus 6 meters square is connected in a circuit. There is a current of 2.5 amperes in the wire. Calculate the drift velocity of the electron in the wire. And the number of charge carriers per unit volume is this much. Right. So this is your formula for the drift velocity. Here Q is the charge, and in that case here it is electron. So we have to replace Q with the electrons. I is simply 2.5. It's an ampere, so no need to change it. N is charge carrier density, which is number of charges per unit volume. So you're just putting it right away, 8.5 into 10 raised to the power 38. Q is the electron, and in that case, it is 1.6 into 10 raised to the power minus 19. Okay. Drift velocity V is the one that we need to find, and the given area is 2.8 into 10 raised to the power minus 6. So after adjustments and shortifying and calculations, you are going to get the answer as, let me get it. This is going to be uh, 6.57 into 10 raised to the power minus 5 meter per second. बेटे शोर नहीं करो, मैंने आपको कहा है, बिल्कुल भी आवाज ना। Now you can see that it is very important for you to remember, otherwise you are going to lose marks for the significant figures error. If you can see that in all the data that is given to you, the number of significant figures are only 2. So your answer should not be having 3 significant figures. So here your answer should be 6.6 into 10 raised to the power minus 5 meter per second. Okay. If you see that in the mark scheme, let me show you. If you see that the mark scheme, the answer that has been calculated in the example of calculation is this, but the answer that is written is this, and for that you are getting 1 mark. Why? Because you have to round it off to 6.57 into 6.6. Otherwise, you are going to get 1 out of 2 in this question, which is not justified, but Edexcel is usually really strict in terms of significant figures, so you have to be careful. A coffee machine is connected across a 230-volt power supply. The heating element in the coffee machine has a resistance of 18 ohms. The coffee machine takes 38 seconds to heat enough water to make a 1 cup of coffee. Calculate the energy transferred by the heating element in 38 seconds. Well, it's pretty easy. Power is work over time, so the machine is doing work, which means energy. And for electric circuit, the power is, we know that V into I, and work is energy. So simply we are going to get VIT. But since we don't know the current in the question, we have voltage as 230, we have no value for current, and we have time as 38. So we have to calculate current, and for current we can easily do V over R, and V is 230 and R is 18. So you can put that in here. Okay, 230 divided by 18 over times 38, and doing all multiplications, you are going to get 1.12 into 10 raised to the power 5. Okay. Now again, you see that the significant figures are only 2 in your data set. So your answer can't have 3 significant figures. Therefore, you have to round off your answer and put it like 1.1 into 10 raised to the power 5 joules. Okay, be careful with that. Explain why the resistance of the heating element increases as its temperature increases. Well, it's pretty straight and very famous question. So you may write that as temperature increases, um, vibration of electron and lattice atoms increases. As a result, what happens? Collision of electrons and lattice atoms increases. And because the collision rate is increasing, what will happen? Flow of electron becomes difficult. Okay. And when the flow of electron becomes difficult, what will happen? The resistance rises. Okay, that shows actually when the flow is becoming difficult, that shows, therefore we say resistance is increased. Question number 13. A student determined the resistivity for a metal in the form of a wire. The student measured the resistance for different lengths of the wire. She plotted the graph shown. The table shows the resistivity of some metals. Reduce which of these metals the wire was made from. The diameter of the wire is 0.24 millimeters. Okay, so I'm considering the graph as a source of precious information. You can see that on the y-axis you have r, and on the x-axis you have length, which is in centimeters. So first of all, you know that the resistivity is some kind of like a number. It is a digital signature given to every metals by nature. So every metal, everything has a specific resistivity value which is assigned to them by nature. So you find them and understand what that metal or material is. So from here, you can see that R over L into A is going to be your length. Sorry, your resistivity, right? So how you don't have the value of resistance here, you don't have the value of the length here, but rather you have the resistance on the y-axis and the length on the axis. So that means if you take the gradient of this graph, you will get both of these values, okay, in the form of in the form of gradient. Okay, so what I'm going to do, I have to take the two points of, because it looks like it is exactly on the point, so I'm taking one of this point, and maybe one is like this point. Okay, so this is the point. Okay, and I believe it is going there. Okay, so let me draw it again. I believe this is the point, and one is, this is the point. I feel like they're like very close to the correct value, but if you see, it is slightly away from the exact value, so I'm taking up this value. However, this looks like an exact value. So I believe that for these 2 points, my gradient value should be 6.6 for this one. And for this one is, I believe, let's take it like 4.2, and let's assume it to be, um, I believe it should be 4.4, no? Yeah, okay, 4.4. And for this one, it is 50. And for this one, I believe it should be maybe 29. Let's take it as 29, or maybe 29.5, I believe, because this point is 28, so it should be 29.5. Okay, so now my values are these two divided by 50 minus 29.5. Okay, and from here the gradient value is 10.7. So that, what I mean is, the gradient was actually R over L, right? R over L is actually 10/7. So it means I can change this thing to 10.7 times now the area. Area was pi r square for the wire, right? And it was given like the diameter as 0.24 millimeters. So radius will be 0.12 times 10 raised to the power minus 3 meters, right? So from here, your density is going to be 4.85 into 10 raised to the power minus 7 ohms meter. Okay. Now you can see that the data given to you is in, again, how many significant figures? Two significant figures. Oh, three. Oh, yeah, yeah. So since here the resistivity is in three significant figures, so you can write the answer as it is, which you have got. So looking at this, the material should be constant. Okay. So you have to write material is constant. And we have to write it because 1 mark is specially for this one. Okay. Question number 14. A student used a semicircular glass block to investigate the refraction of light. He directed a ray of light onto the glass block as shown. State why the ray of the light does not refract as it enters the glass block, because it is entering along the normal line. If you can see that the normal, if drawn here, it is like this, and the ray of light is also entering along the normal. So when the incident ray and the normal ray have no angle between them, like they are along with each other, it means the light is not going to change its path when it is moving from air to glass. Okay, no change at this point. Why? Because ray is following or entering into the glass along the normal. Okay, so remember that there is no refraction angle, and you can get it using this thing. Okay, so let me show you quickly that why we don't have any change in the angle. So for air, it is this. The angle of incident here is 0 because normal and incident ray both have parallel to each other. So here you will have 0 degree. Then N2 is 1.5 for glass. So the angle of refraction will be this one. So this whole thing will become 0. 0 divided by 1.5. From here, sine inverse. And sine inverse of 0 into divided by 1.5 is again 0. So you can see that the angle of refraction is 0. It means the angle of incidence is 0. Therefore, the angle of refraction is also 0. And when the angle of refraction is 0, it means the light is not going to change its path, right? Okay, state so for this one, you will just say that the light is entering along the normal. The glass has refractive index of 1.5. The ray of light is refracted at a curved surface of the block. Calculate the angle of refraction. Now you can see that the light is moving from here, and you have to keep your D like this. And when you keep your D like this, you know that this should be your, your D's zero line. Okay, like this. Okay. So we know that when light is moving from here, now this is your angle of incidence. Okay, this is not angle of refraction because light is moving from glass to air again. So outside is air. So the light has to move away from the normal. Okay, because when light moves from glass to air, it has to move away from the normal. You cannot make this one because this will be wrong, because the D has to be placed on the normal line like this, as I have depicted or demonstrated through the red D. So just applying the Snell's law, N1 sine theta I equals N2 sine theta R. N1 is definitely glass. For that, it is 1.5. Sine incident is 35. For air, it is definitely going to be 1, and theta R is going to be, I'm just calculating it. And when we do the calculation, it is going to be 59.35. And since you can see that your angle is in two significant figures, so your answer should be rounded off to 59 only, right? So this should be your answer. Complete the ray diagram to show the path of the ray as it leaves the glass block, which I have explained you again, that this is how you will put the glass. This will be your 0. This is the 90 of the glass, so your angle will be somewhere here. Okay, because this is normal and this is refracted ray, so this is going to be 59 degrees. Okay, cannot be in this side because this will be wrong, because D only gives you angle in this direction, not in this direction. Okay. Now the student moved the glass block so that the ray of light was incident on the curved surface at the critical angle C. As shown below, determine the distance x. A refractive index of the glass is 1.5 and radius of the glass block is 45 millimeter. Okay, good question. So you can see that this is the central point. Okay, this is the central point, and let me mark them with another color. So let me take the green. Okay, so if you take a look, if this is the center, then this whole thing is your radius. I mean, radius of the circle. Okay, this is R. And if you take this one, this is also the radius, because from the center to any point on a circle is also radius. Okay, this is also radius. However, this distance is x, which is given. So this distance is x. And if this distance is x, so what about this distance then? What about this distance then in pink? This should be definitely x minus r, right? For example, if this is whole 10 and I say this is 4, so this, how much this one should be? This one should be 6, so 4 plus 6 is 10, right? So I can write 6 as 10 minus 4. Okay, so x is 10 and r is 4 is r, so this distance is going to be x minus r. Okay, I hope you understand how this is x minus r. Now you have everything, and if you get the critical angle through some means, this is your angle 90, so I'm calling this triangle as A, this point is B, and this point is C. Okay, so for triangle ABC, I can say that this side is my base, this side is my perpendicular, and this side is my hypotenuse, right? And if I get the angle of criticality C, then I'll be very easy. I'll be able to get x minus r, and when I'll get x minus r, I'll be very like comfortable to get the x. So what I do first, I know that n equals 1 over sine C, correct? Where C is the critical angle, and n's value is given. So I'll just do this 1 over sine C equal 1 over n. So 1 over 1.5, right? And if I do the calculations for the critical angle here, this is going to be 41.8, yes. And again, you can see that the angle was in two significant figures, so therefore I'll write the critical angle as 42 degrees. Okay, the critical angle here is 42, which I'm going to put in here. This is 42 degrees. Okay, so now if you see that you don't have the value for the base, however you have the value for the radius, and the value for the radius is how much? 45 mm. So you can write 45 into 10 raised to the power minus 3 meters. Okay, and this is also 45 into 10 raised to the power minus 3 meters, correct? So now you have pretty much theta available, and all you need to do is just to apply the right trigonometric ratio, and I believe a sine theta will be very good one here, perpendicular over hypotenuse. The angle here is definitely 42. Perpendicular is x minus r, and hypotenuse is r. Okay, so what I know is the answer for x is going to be this, equals x minus r. Okay, and sine 42 into r plus r equals x. So now you just need to plug in the values and get the calculations, and when you do the calculation, your answer is going to be 0.075, which is rounded off to two significant figures, and the answer becomes 75 mm. Okay, because your all the data of the length is given in two significant figures, so your answer should be in two significant figures as well. Question number 15. The photograph shows a flame detector. The flame detector uses the photographic effect to detect ultraviolet radiations from fire. Explain how electrons are released in the photoelectric effect. Okay. Okay, here's the answer. So when the incoming photons are incidented on the metal surface, what happens actually, if the energy of the incoming photon is greater or equal to the work function of that metal, then these electrons, then these photons will be absorbed, not electrons, my apology. Okay, then these photons are absorbed inside the metal by electrons. Okay, you have to write absorbed by electrons. So when they are absorbed by electrons, then what will happen? Some of the incoming energy of the photons will become kinetic energy, and some of it will be used to free them up from the prison. Okay, because inside they are like in prison. So some of the energy will be used to free them up, and that will be called as work function. And the remaining amount of the incoming photon energy will be transferred to the electron as their kinetic energy, like additional amount of energy. Okay, so that all happens according to the photoelectric effect equation, which is hf equals phi plus ke. So you can say that, for example, if the incoming photon was having the energy of 10, then some of the energy was used to free the electrons inside the metal, like from the prison. So 4 joule is gone to free them, and the remaining 6 will become the kinetic energy of the free electrons. Okay, this is how you need to write up these 4 points. Okay, I hope you understand that. Okay, a fire emits photon of ultraviolet radiation with a wavelength of 380 nanometers. Show that the energy of each photon is about this. Very easy. E equals hc over lambda. You know that. And all you need to do is just to put in the values. Divided by 380 times 10 raised to the power minus 9. And the calculation give you the answer as 5.23 into 10 raised to the power minus 19 joules. So this is giving you in 3 significant figures, but the data has either 1 or 2 significant figures, so you can round it off your energy to 5.2 into 10 raised to the power minus 19 joules. Okay. 15 to calculate the maximum kinetic energy of the released electrons in EV. Okay, so work function is given to you, and you should know that 1 EV is actually equals to 1.6 into 10 raised to the power minus 19 joule. All right. So the energy of the electron that you have already calculated, the energy of the photon, the energy of the photon uh, is 5.2 into 10 raised to the power minus 19, right? शोर नहीं करो. Okay, so you will just write the photoelectric effect equation, which is HF equals phi plus KE, right? And this HF is actually the energy of the incoming photon, and it is going to be 5.2 into 10 raised to the power minus 19 equals the work function is given as 2.2 eV. So 2.2 into converting it first of all into joules to, because we have the data energy of the incoming photon is in joules. Okay, so plus ke. From here you will get the kinetic energy of the electron, and that is about 1.68 into 10 raised to the power minus 19 joules. Okay, now this is in joules and they're asking you to find out in kV, so all you need to do is just to divide that with 1.6 into 10 raised to the power minus 19. And when you do it, you are going to get 1.05 eV. But since you have the significant figures of the work function too, so your energy should also have two significant figures. Therefore, it will be rounded off to 1.1. Therefore, it is 1.1 eV. Ultraviolet radiation with intensity of 8,000 watt per meter square is incident on the detection surface. Uh, the detection surface has an area of 0.02 meter square. Determine the number of photons incident on the detection surface each second. Okay. It is a typical not typical question, a little bit conceptual but not that much. I equals the power over area. First of all, I is intensity, and from here intensity is 8,000, power is not given, it is this, and the area is 0.020 meters squared. Got it? And from here you are going to get the power as 160 watt. Okay, now power, we know, is actually the energy over time, and this is the power of so many photons which are being incidented on the metal surface. So we can say that the energy per unit time of one photon is not 160, rather it is the combination of so many photons energy together making it 160 watt, because you know that energy travels in the form of packets. Light travels in the form of packets, and we call those energy packets as photon. And just one photon cannot have this significant amount of energy. 160 watt per second is something huge. 160 joules per second, that is called 160 watt. 160 watt means 160 joule is being transferred to the metal surface every second. That means it is not a function of one photon. It means there are billions of photons added up, their energy packets added up into this significant amount of energy transfer per second. So we will say that this is the power of so many photons together, right? So from here they have written each second, right? And what I'm going to write, n times energy divided by 1 equals 160 watt. Now what is the energy? You already calculated that in the previous part, and that energy is 5.23 into 10 raised to the power minus 19, right? So n into E from the previous part was 5 point from the B part, I believe, 10 raised to the power minus 19 joule. Got it? So you are just putting in the value here now. Okay, so n into 5.23 into 10 raised to the power minus 19 divided by 1. Okay, um, equals to 160 watt. And from here, 1 times 160 divided by 5.23 into 10 raised to the power minus 19. And from here, you are going to get the value for the photons as 3.1 into 10 raised to the power 20. Oh my God. So now you can see that this is equivalent to 3100 billion photons. Okay. So 3100 billion photons are actually being incidented on the metal surface, and they are transferring the power of 160 watt to the electron, and due to that they are coming out. The detection surface is part of an electric circuit. The electrons released cause a current in the circuit. The intensity of the ultraviolet radiation incident on the detection surface increases. Explain explain how this will affect the current in the circuit. So you can see that when you increase the intensity, actually it means that now more number of photons are being incident on the metal surface. Okay, more number of photons are coming per unit time, and they're incidented on the metal surface. And when more photons are arriving, what will happen? More photons will be eaten up by the electrons, and they will get more photons. So when more photons are absorbed by more electrons, it means more electrons are coming out of the metal surface. So when more electrons are coming out of the metal surface, they will be running more and more. So when more flow of electron, that means more number of charges are flowing. More number of charges are flowing means more current do you have in the circuit. So you say that the current increases. Okay. A student directed light from a laser onto a diffraction grating as shown. A series of bright dots was formed on the screen. The light from the laser is coherent. State what is meant by coherent light. So remember that the coherent means there is a constant phase difference between the two consecutive rays of light and the constant frequency as well. So two rays in a laser, both of them will have a constant phase difference. Okay, so these two will have the constant phase difference. These two will have a constant phase difference. However, the frequency will remain constant. If these two conditions are satisfied, we say that the light is coherent. Explain why a series of bright dots was formed on the screen. Okay. So you know that when the light is incidented on the diffraction grating, what happens? It diffracted in various directions. Okay. And when so many rays are diffracted in different directions, what will happen then? At some point, they will do interfere with each other. Okay. So the points where they do constructive interference, you will see bright spots, and the points where they will do destructive interference, you will see dark spots. Now, what is the condition for the bright spot? When they are referring to the bright dots, it means you have to you have to write down the conditions for the constructive interference. Okay, so you need to write that the bright spots are produced when the path difference um, between the two rays is full multiple of wavelength. Okay, and when this condition is satisfied, which you can write as d sine theta equals n lambda. Okay, when this condition is satisfied, then rays superpose and the resultant amplitude is very much bigger, which is resulting in the bright spot. Okay. The diffraction grating has a grating spacing d of 1.07 into 10 to the power minus 6 meter. Calculate the angle um, between the central maximum and the first order maximum. Okay, so this is the central maximum where you see n equals 0, and the first order maximum means the bright spot. Okay, this is the bright spot. And you have the wavelength this. So pretty much straightforward. You just write the formula d sine theta equals n lambda. D is 1.07 into 10 raised to the power minus 6 into sine theta. This is what you need to find the angle. Okay, and n is 1 because for the first order n is 1, and the lambda is 532 times 10 raised to the power minus 9. From here, the angle is going to be 29.8. Since the angle should be in two significant figures always, so we round it off to, I believe, 30. Okay. Okay. The student observed first and second order maxima. Explain why it is not possible for a third maxima to be produced. Good question. So how do you know that the third maxima is not there? For that, you need to write the formula again. D sine theta equals n lambda, and you make this sine theta to be maximum, because this is something fraction here. Okay, so for example, this is 4 and this is 0.5, so 0.4 divided by 0.5 is actually 2. It means this fraction is reducing up this number. I mean, your total number is being decreased because of the sine theta, because sine theta is a fraction. So somehow, in order to find out how many maximas are possible, for that you need to turn this fraction into a whole number. Okay. So in order to convert this fraction into a whole number, what you need? Sine 90. Okay. So when theta is 90, sine 90 actually turns into 1. Otherwise, for no other angle, it is 1. So sine is only 1 when you have theta is 90 or 270. So, and at 270 it is minus 1. So sine 90 should be put in here for the evaluation or calculation of maximum order of maxima produced on the screen. Okay. So what you are going to write, d sine theta equals n lambda, and for maximum number of spots, you have to put sine theta as 1 because theta will be 90. Okay, so simply d equals n lambda, and d was how much here? D was 1.07 into 10 raised to the power minus 6, and n is something that you are calculating, and this was 532 into 10 raised to the power minus 9. And when we calculate it, it is going to be this, and it means you are going to get only two maximas or second order up to maximum. Therefore, we need to write, therefore we will not see the third spot as maximum possible spots are 2. Okay. The student replaced the laser with a lamp that produced a narrow beam of white light. Describe the pattern that formed on the screen. Okay, so you know that when the white light is incidented on the diffraction grating, what happens? It turns into 7 colors. Okay, and you should know that white light is a combination of 7 colors, right? So you need to write that when light is incidented onto the diffraction grating, it dispersed into the 7 colors as and shown on the screen. Okay, and this is the central spot, and this is the central spot, and on the both sides you will see the spectrum of 7 colors. Okay, now the question is where you will see the red color and where you will see the violet color, because red and violet are always on the borders of the spectrum. So the center spot will always be light first of all, and what about the other colors and how you will see them? So first of all, you need to know that the central spot is always white, because all the rays which are interfering here, they are covering up the same distance, so there is no path difference or phase difference between all the rays, all the 7 color which are arriving at central spot. So when they arrive with same phase difference, path difference at central spot, they become white again. Okay, so they rejoin together, they fuse into each other and turn into a white spot again. So the central spot is always white. However, you know that d sine theta is equals to n lambda, so that shows that the angle of diffraction, which is sine theta, is directly proportional to the wavelength. Okay, so violet has the shortest wavelength. Okay, shortest, and the red has the longest wavelength. Okay, so what does that mean? It means that the angle of deflection for the red color will be the highest. It means that it will move away, most away from the central spot, whereas the violet color will be the very nearest to the central spot. Okay, so farthest, this point is the farthest one, and this one is the closest to central point. Okay, both are from the central point, remember that. Okay, question number 17. Question number 17. Water in a water bath is heated using an electric heater. The heater circuit is switched on and off by control circuit shown. The cell has negligible internal resistance. The thermistor is placed in the water. When the potential difference across the thermistor is above a certain value, the heating circuit is switched on. Explain how increasing the temperature of the water affects the potential difference across the thermistor. You should refer to conduction electrons in your answer. Okay, no worries. Okay, so you should know that there are two kind of electrons. One are the valence electrons, and one are the conduction electrons. And in a semiconductor, inside a semiconductor, we have actually a theory which is not part of Edexcel, but it is good if you remember it: energy band theory. Okay, so this theory suggests that in semiconductor, you have one kind of valence band and one kind of conduction band, CB. CB is for conduction band, VB is for valence band. And all the dots that you are seeing in the valence band, these are the electrons which are residing, they are living in a valence band. And when you rise the temperature, actually, they absorb energy. So all these arrows which are going into the valence band, they are showing you that the heat is being absorbed by the valence electrons. So these valence electrons, when I mean gain the energy, they jump into conduction band. So the current that flows in a semiconductor, it is all because of the conduction electrons. If the conduction band has some electrons, if the conduction band have some electrons in it, which are jumping from the valence band, then the current will flow, otherwise not. So when you rise the temperature, actually the valence band electrons gain energy. This is what it is written in the first line. When temperature increases, the valence electrons are gaining energy, which is being referred into here, okay, by these inward arrows. Yeah, these ones. So due to this, the conduction electrons are increased. Why? Because when they increase, I mean, when is rising the temperature and they're absorbing the energy, they will be able to jump to the conduction band, right? So all the electrons that are living in a conduction band, these are called conduction electrons. Okay, so as you're rising the temperature, valence band are gaining energy and they are jumping into the conduction band. Therefore, the number of conduction electrons are increasing. And as the conduction electrons are increased, we know that the flow of current is only because of the flow of the conduction electron. So we say that the flow of conduction electron has been increased, due to which we will say the current increased. And we know that there is an inverse relationship between current and resistance. So if the current has been increased, then the resistance is definitely going to be decreased for the thermistor. Now, if the resistance is decreased, of course, the potential difference can also be referred as the decreased value of the potential difference. As you know that the voltage and resistance are directly proportional to each other. Okay, so thermistors, I mean, the voltage that is being used by the thermistor is also decreased. And when this voltage falls below certain value, then the thermistor is switched off actually. Okay, so all this explanation is actually for this circuit, right? So as you're rising the temperature here, just a quick summary, as you're rising the temperature here, the resistance decreases. And when the resistance decreases, for example, here it was previously 4 volts, here it was 2 volts, because here the 6 volt is the supply. So supply is always equals to the consumption. So 4 volt was being utilized here, 2 volts being utilized here. Just for an example, these are the dummy numbers. So as now the temperature is increasing, the resistance is decreasing. So because the resistance is decreasing, the potential difference that is being used here, it will also be decreased. For example, 1 volt now. So because it is decreased to 1 volt, then it cannot remain 5 volt, 2 volts anymore. It has to increase to 5 volts, right? Because whatever the supply is, it has to be consumed equally. So if it is 1 volt here, it can't be 2 volt, it has to be turning into 5 volts, so that the total amount of the supplied voltage remains same. So this is what actually written down there. Hope you understand that. B, the heater will switch off when the potential difference across the thermistor is 0.9. Okay, 0.9. So let me write here 0.9 volts. So the temperature of the water should reach 65 degrees. The resistance of the thermistor at 65 degrees is 56 ohms. Okay, here it is 56 ohms. The resistance of the fixed resistance is 300. Determine whether the uh, whether the heater will switch off when the water temperature reaches 65 degrees Celsius. So fixed resistance is 300 ohms, and here it is 6 volts. So we just need to check whether at 0.9, I mean, what is the voltage at this resistance, 56 ohm resistance, 300 ohm resistance, 6 volts. So they're saying at 0.9, it has to be switched off. So this is our standard value. So this is our reference value, and we need to check by calculating it whether we are getting 0.9 or not. By using all this given data, if we will receive, or if we get the voltage across the thermistor as 0.9, then it means the thermistor was switched off, otherwise not. So let's check. And how do we do it? We can use the potential divider equation for this one. Okay, so potential divider equation is very easy, and you know that it is equals to small v over capital V equals small r over capital R. And small v is again for your chosen component, and your chosen component is definitely thermistor, because you are measuring the voltage there. Okay, and this is the chosen component resistance. Okay, and our chosen component is definitely thermistor, because we have to find out. So this resistance small r and small v is the small v is the voltage for that component for which you want to calculate the voltage, and small r is the resistance for that component for which you are measuring the voltage. Then this capital V is the total supplied value of your circuit, and this is the total resistance of your circuit. Okay, now small v is what we need to calculate. The capital V is 6, small r is actually 56. It is given for the thermistor, and the total one should be 300 plus 56, right? Because they are connected in series. It's a single path. You can see the whole circuit has a single path. So if you have a single path circuit, it means the current is always flowing in one direction. So such circuit is called series circuit. So from here, 56 divided by 356 times 6, and from here if you get the value, it is 0.9 volts. Now you can see that, and you can write a conclusion that since 0.94 volt, this is actually calculated value. Okay, and it is greater than the reference value, which was 0.9. Okay, 0.9. And they have said that if the value of the voltage reaches 0.9, then it will switch off. Since it is greater than the required turning off voltage, so we'll say heater will not switch off. Got it? Hope you understand that. Question number 18. A student directs unpolarized light through a polarizing filter. After passing through the polarizing filter, the light is plane polarized. Explain the difference between unpolarized light and polarized light. Plane polarized light. Okay. So for such question, remember three pet points for answering this question. Number one, um, the pet answer is unpolarized light travel in all directions or all planes, whereas the plane polarized light travels only in one plane. Okay, and in the direction in which the plane polarized light is traveling, it includes the direction of the propagation of light. Okay, so the direction of the propagation of light, for example, light is traveling this way, so it is quite possible that I mean, the wave is polarized in this direction either or in this direction. Okay, so and if it is polarized in this direction, we will say that the plane of polarization is parallel to the direction of propagation of wave. And if it is moving in this direction, I mean, for example, the light, if the light is oscillating up and down and the traveling direction is rightward, then we will say that um, the polarization takes place perpendicular to the direction of propagation of wave. Okay, so we have two kind of polarizations, either horizontal polarization and vertical polarization. So vertical polarization means the oscillations are up and down, whereas the wave is moving forward. And horizontal polarization means the oscillations are parallel to the, I mean, right and left, just as the wave is moving right. Okay, so in that case, we will say that the direction of the oscillation of the wave is parallel to the direction of the propagation of the wave. These 3 points are like pet, and you need to remember. Question number 2. The student rotates the polarizing filter. Explain why rotating polarizing filter will not change the intensity of the light that pass through the filter. Okay, so before writing the answer, let me explain you first. So for example, the light is coming with intensity I, and you have placed a vertical polarizer in front of it. Okay, so this light has two components, horizontal and vertical both. So if this is a vertical polarizer, what will happen? The horizontal component is blocked, and here you will only get the vertical component of the light. So the intensity becomes half initially. And if this light is coming, which is unpolarized light, UPL, and this is polarized light, PL. So if the intensity is I and it is coming here, and you have a polarizing filter now which is horizontal, so what will happen? The vertical component will be blocked, and you will again get the half of the intensity, but this time here we will say the light is vertically polarized, and here it is horizontally polarized. Okay, and in both cases you can see that the intensity is same, right? So this is like your one point, and the second point is, in both cases the intensity of the plane polarized light is same, which is I by 2, as compared with the initial one, which was I. Okay. Um, the student arranges 3 polarizing filters in different orientations. The arrows in the diagram shows the initial orientation of the plane of the polarization of each filter. The student rotates filter 2 by 45. The intensity of light that passes through filter 3 changes. Explain how rotating filter 2 by 45 from its initial orientation affects the intensity of light passing through filter 3. It's a good question, and I will write the answer in detail. Before going into the answer, I have to explain you what is actually happening here. So you have to see that, for example, the unpolarized light UPL is coming, and it has an intensity I. Okay, so you can see that these two polarizers are vertical. What does that mean? It means that the vertical component VC and the horizontal component HC. So the horizontal components here will be blocked by these by the filter one, and it will only allow the vertical component. And this vertical component, when it will arrive here, it means now the intensity has been reduced from I to I half, and the same intensity of light will pass through filter 2, because this is also vertical, so it will allow the light as it is, and it will be moving to the filter 3. Now you can see here that it is a filter which will only allow the horizontal components of the light, and since the incoming light is only having the vertical component, so all the light will be blocked, and at the other side of the filter 3 you will get zero intensity. So initially this is the condition in you're not getting any light. Okay, now what happens, now you are actually going to rotate this. I mean, you are going to rotate this filter 2 by 45. Okay, so what does that mean? This, that the vertical light that is coming here, it is now actually um, polarized at 45 degrees. This is what I'm saying. Okay, so light is polarized here at 45 degrees. All right. So when the light is polarized at 45 degrees, what will happen then? It means the light is now moving this in this direction. So in this direction, if it is moving, it means it has two components. One is this, which is horizontal component, and one is this, which is vertical component. Okay. So the vertical component, of course, is going to be blocked by the filter 3, because it is not allowing the vertical components. It will only allow the horizontal component, whereas the horizontal component is part of the polarized light at 45. It will have a horizontal component that will be starting passing through it. So here the intensity cannot remain zero, just as before. The intensity will become non-zero. So your answer is the intensity of light has been increased from zero, which was before, now to some other value. non-zero value. Okay, so that is the answer to this question. Now whatever I have explained you, I have written it here for you. So you can see that as seen in the figure, the filter 1 and filter 2 are vertical polarized. So what does that mean? It will only allow the vertical component and blocking the horizontal component. So the horizontal components of the light will be blocked by them, and only the vertical components will be allowed. Okay, and therefore the intensity of the filter 1 will be as I have and will not change for filter 2, because filter 2 is also vertically polarized, so the intensity at 1 and 2 will remain the same. As the filter 3 is horizontal, so it will block vertically polarized light from filter 2, and as a result intensity will be 0 at f3 filter 3. Okay, so that happens before the rotation. Now after the rotation, what will happen? You can see that when the filter rotation of the filter 2 is done by 45, then the light is polarized at 45 degrees, and previously it was being polarized at vertically, that means 90 degree, right? So previously it was 90, now it is at 45. Due to this, due to this 45-degree polarization, the light will have two components, the horizontal and the vertical, and the horizontal component will be allowed to pass through filter 3, and the vertical component will be blocked by filter 3. As a result, we will say that the intensity of light at f3 has been increased from 0 value to some other value. Okay, hope you understand the answer to this question. Please like and subscribe my channel. This is the end of unit 2 exam, and if you have any question, please let me know, and I'll be very happy to help you all through your questions. Okay, up till then, take care, good night.